in an industrial scale, and of course to have a full-scale demonstration that, as you saw in the video, it took place in Germany at the new DuraBast facilities. This phase of the project has been completed in partnership between the German BAST and the Dutch Heisman. Herbert from Heisman is not able to be here, so Bastian Wacker from BAST will complete the two presentations. So he will speak about the manufacturing process in the asphalt plant, and as well what he did at the DuraBast, the accelerated loading test, the induction heating demonstrator, and he will show us the findings during those testing. Please, you have the floor, Bastian.
Thank you very much for this introduction words, and sorry for Gerbert. His flight was cancelled and it was not possible for him to attend this meeting. So I try to give my very best to explain what he did with Heymans, and after this we go to my section with the accelerated pavement testing. We heard a lot about the laboratory testing so far and the nice findings, what they found out. Now we come to a topic with a full-scale demonstrator, which is completely different to laboratory scale. So I hope that I can give you some feeling about our work, what we did, and our findings, and come to a conclusion in the end, of course. In October last year, we had a nice live event, live demonstration event at BAST, and here you see all our group members of HEALROAD, but of course there are different other people in the background to prepare a live demonstration event or a full-scale demonstrator. There are a lot of people involved into this work package 5 during the HEALROAD project, and I want just to thank everyone for his effort and his work. Now we come to the upscaling process. In the laboratory we can mix this asphalt mixture very easily, but to translate it to the full-scale asphalt plant, we have to translate the raw data or the material data with the laboratory results. And Heymans did this in the Netherlands. And after a first test in the full-scale asphalt plant, they produced asphalt slabs, like you see here in this part, and used the ersat for first results from full-scale mixing process. During the mixing process in a conventional asphalt plant, it was found out that you need a mixing time a little bit longer than normal. It's about 15 seconds, but anything else, that's standard equipment. You just have to use an asphalt plant where you can add additives, and then everything is fine, and so it's easy to include in the European asphalt market if it comes to an implementation. After this upscaling process, we produced a full-scale demonstrator, and therefore we provided an area on our new test facility in Germany. It's called DuraBast, and it's located in the west part of Germany, close to Cologne. And if we go now closer into the map, you see BAST is located in the east of Cologne, and right in the middle between BAST and Cologne city center there is a big highway junction. In this highway junction, there is the new test facility DuraBast located, and DuraBast is staying for demonstration, investigation, and reference area. If you want to get more information, please talk to me later on, but that would extend my presentation here, so sorry for this. But now you know where we placed our demonstrator. Our demonstrator was constructed in for different goals. The strong support construction was the first goal, so we decided to use standard asphalt materials in the base layer and the binder layer. On top of the binder layer, we had the drainage level, because in the project we decided for porous asphalt. The second goal was that we get an homogeneous conditions over the whole test section, that we can find a good solution and find results over the whole place. Our main research object was the HEALROAD surface layer, and this we prepared with a porous asphalt, and it was 5 centimeters thick. All the dimensions was combined or focusing on a Netherlands standard construction, and therefore we decided for 5 centimeters of surface layer. The asphalt material was mixed in the Netherlands at the location of Heymans and transported via trucks with isolated trailers to Germany, and we placed it on the in mid of July. And all the temperature were measured during the transport or in the end of the transport, and before we started to pave the surface layer, and during the compaction process, so that was everything in a nice window and everything was working fine with standard equipment. So we don't have to adjust something on the paver or on the rollers, only like you build up porous asphalt conventionally, you don't have to think about anything else. After the construction, we had a demonstrator which was approximately 50 meters long, and we placed 2 loading sections. One was our so-called reference track, it was HR1, and this presentation is more on HR2, where we implemented the healing actions too. So we had these 2 loading sections. If I talk about loading, we used an accelerated pavement testing program, and in BUS we are using the mobile load simulator MLS30. The MLS30 is equipped with 4 super single loading tires in a closed chain. And to explain it a little bit better, the loading wheel is driving over the surface every time in the same direction. Then the tire gets lifted up again, were moved backwards and lowered to the surface again, and there are 4 wheels inside, so every time one wheel will stay on the surface. Because of the goal of this research project to get stone loss, that was the only thing what we could realize in this small and short period of time. That was our idea. We decided to lift up the load to 75 kilonewtons. The standard load in Germany, we load with 50 kilonewtons compared to our design guide. And we had a speed of 2,000 loading cycles per hour. That's approximately walking speed. That means we have a lot of pressure in a long time when the tire is on the surface, and additionally, we had a sideway movement, that the machine was moving 350 millimeters left and right. So the speed was very low, and we could introduce shear forces into the surface layer. The lateral movement is working during the loading process, so we don't have to lift up the machine and put it sideways. It's during the loading process, and it's going sideways with 4 millimeters per second. This video you saw already in the movie in the beginning. There you see how the MLS is moving sideways. It's a time-lapse video, of course. It's not a in real speed, because that was much not that fast. Sorry. During our preparation of the work package 5 and the loading program, we decided for the failure criteria stone loss, because then the first cracks appeared between the aggregates inside the bitumen film, and so we decided we go for stone loss. And Heymans used an AirSat system. It's like a laboratory scaled unit where a wheel is moving over a surface, and yeah, it's very bad for the surface and lose the stones. And therefore, Heymans produced 4 slabs for this laboratory production, and then we drilled out cores from Durabust after paving, so that we had the same situation in the lab like outdoors. At BUST we used, I told you already, the HR2 for the healing actions, and if I now go for our loading program, we had to decide for a short period of time what we want to do with our loading. And in our group we decided for 150,000 loading cycles per loading area, and that took about 2.5 weeks for loading, 2.5 or 3 weeks. And yeah, then our budget was over for the project, unfortunately. So we hadn't designed a frame for our loading. This is the 3.5 meter long loading area where we have constant loading with the MLS, the center line, and then we moved 350 millimeters to the left and 350 meters to the right. We designed 2 samples, I call it samples, with no healing, so there's no maintenance work during the loading process. And then we had different samples after different loading periods. So after 20% of loading, we did a first healing just on this one sample. After we finished the healing action, we waited some time to lower the temperature again, and then we started the loading process again. Then after 40% of healing, we did another healing action on another sample, and so on. And that was our idea of loading our demonstrator. The healing action was performed by SGS from the Netherlands, and they took the whole machine to Durabust and operated the machine to our different intervals of healing actions. And here you see that first coil and the second coil, and if the first coil is moving to the first white color, we started just this coil and the second coil was not in use, and then the whole machine was traveling towards the next white color lane, and we just had to adapt the 2 induction heating machines. During these healing actions, we used infrared cameras to monitor the temperature, and our idea was to reach a surface temperature of 100 degrees Celsius. And how you see, we had 4 healing actions. This one was the first one that was around 95 degrees Celsius, and all the others are very close to 100 degrees Celsius. And that was our goal to go for this healing. Even here I have a small time-lapse video, and I just want to inform you there are 2 cycles. So we moved the machine once over the sample, then backwards, and another time over the sample, and the whole video what you see is in reality 30 minutes long, and I used a factor of 40, so it's a little bit lower, but you see here the maximum temperature, and if you take a look to this temperature, then you see how the temperature is changing, during the healing process. And as you see, it's very homogeneous, and the mixing was very nice, that there are no clusters available or not seen in the pavement. And that was one of the goals what Daniel was mentioned earlier. So the mixing process with this new or with this small fibers was working very well. And then we waited until the temperature dropped again until 40 degrees Celsius to start again or to to finish our inspection and evaluation process. So I told you that we had different loading periods. For example, if you look here for the first healing action, we had a loading in advance, and after this loading, we went to the surface and tried to get all the stones, all the loose particles from the surface and calculated these loose particles. And we did this every time after finishing our loading process on each day, or in the middle of the day too. And in the table you see the amount of, I called it stones, what we found on the surface and picked up from the surface. And we had an area of loading of 4.2 square meters. And if I now calculate just the gram, the total gram what we received, we got a special amount of gram per square centimeters. It's just a calculating thing. Just keep this number in mind for the next slide too. And I just want to show you an example what we picked up from the surface, and therefore I marked one lane, and this kind of stones we picked up on the 7th of November last year, and that's mostly the average over the whole day, over the whole experiment. We did surface inspection with the AirSat-2 at Heymans, and therefore just that you know the dimensions of the surface area, I marked it with the yellow box here. And after 4 experiments with 4 slabs, we had an average of 11 gram of stone loss during the experiment of, I think it's 24 hours, one experiment. And there we have roughly a tenth of the stone loss per square centimeters in this laboratory test. If we now use drilled cores from Durabast before we loaded the area, we have a different system, and at the moment we're still thinking about these numbers and have to analyze these numbers, and we are in deep discussions with each other in this work package to find a solution and to get a good conclusion about these results to each other, the field results and the laboratory results. Every time when we used our hands to pick up the loose stones, we did surface pictures of each individual sample. And after the loading process, we went through it and looked for the stone loss. And if you remember, we had 260 stones in the surface inspection. And if I now go to the surface pictures to find the exact position where the stones are coming from, something like this was happened. There was a stone before we started loading, and after 60% of loading, the stone was gone. So this is very easy to say, okay, the loading process with the MLS was fruitful and we had an impact to the surface. Even with the other example, what I will show you here, there was a stone on the surface before we started loading. After 20% of loading, there was a crack inside the aggregate, and after or between 80 and 100% of loading, the partial stone was gone and went somewhere else. So these are the things what we want to heal with the with HEALROAD or with the induction machine, and makes clear that we have to find a solution or a system to detect at what time we introduce the healing process. It's a visual thing. With these surface pictures, I did another, I tried to find out a correlation between healing action and no healing action. And during the pickup system, we had 260 stones. During the surface picture evaluation, I found out that only 55 stones were loosened in this part, in the whole area with this 3 or 6 samples. So a little bit disappointing, because I thought 260 stones are nice, but 55 stones are a little bit less. And if I now go to the sections where we have nothing, no healing action at the whole period of time, we found out that there's not really a correlation between this sample and the other sample with no healing. So it makes it very hard to do a conclusion. And then if you see to the other samples, every time where this vertical lane is marked, there we had this healing action. Unfortunately, with this first APT program for this topic, it was not possible to find a solution, unfortunately, for the right moment for the healing action. So there's more research definitely needed, and to get more data for the APT, because in the laboratory we have different samples, a lot of samples what we can produce and go for another run. At Durabast or in the APT program, we have to look for different projects, and we have just one goal or run for experiments, because it's very expensive and takes a lot of time. And we learned a lot during this program to improve next projects too. So now I will come to my conclusion about our upscaling process. The full-scale demonstrator was paved with standard paving technology. That was one goal for the proposal, that we don't have to improve our techniques. And very important is that we had very homogeneous surface characteristics without clusters or other local events or problems. So that's a very nice conclusion. APT program was performed with 150,000 loading cycles. That's quite short and very short for this strong conditions. We did surface inspections and surface pictures, but unfortunately we had no correlation between surface inspection and surface pictures to HEALROAD actions. That could be because of the short loading program for a very good construction. That we had a very low lateral movement speed of 4 millimeters per second. Unfortunately, the speed cannot be adjusted by the machine. And it was the first full-scale test for this kind of topic. I have no connection found to other APT programs worldwide. So we had a lot of things to learn during this program, and I think we did this definitely. The laboratory research with the AirSat is still ongoing. The last results came in yesterday, and we try to find, or we will compare to our findings so far. And in my opinion, we have to do more research in this field to get more APT data. But of course, we have to find a solution how we can detect the right moment for healing actions in full scale, in reality, and not just going there and do some healing actions. There are some research in the lab, but to transfer to the full scale test, it's quite hard at the moment. So thank you very much, and have a nice day.
Thank you very much, Bastian. I have to say that it was a quite interesting or amazing experience, because a few months before we had this induction healing technique on a paper, and 1.5 years after we have it on the real road. So the solution was basically ready to be on the market and to have this business exploitation. Now, well, one of the problems is coming. As you all know that you are working in the sector, there is not only one, there are several solutions that can improve the pavement, can improve our roads. So we need to identify which could be the innovative elements. So in the next step of the project, there were two different studies focused on which could be the environmental impact of the new technology, how we could